I'd like to welcome everybody to Tech Tuesday. I'm Jim Bush, your host today and one of the support managers here at Datalink. This is the second installment of the Tech Tuesdays for 2014. We're glad you're able to take time out of your busy schedules to join us. I'd like to cover some quick housekeeping and then we can get this show started. Throughout the presentation today, Datalink Advanced Technical Support Engineer Chris DeBow is going to be answering your questions through the Q&A tool. You should see that on your screen. The Q&A transcript will be emailed after the event so that everybody can see what the questions were. The recorded version of this event will be available online shortly after the live presentation. Shortly is probably a couple of days. If you have any questions after the event has concluded, please feel free to send those to techtuesday@datalink.com. At this time, I'd like to introduce our presenter for today, Datalink Principal Architect Jason Anderson. Take it away, Jason.
Thanks, Jim. Good afternoon, everybody, and good morning for those of you that are dialing in from the Pacific time zone. And thanks for participating in the second Datalink Tech Tuesday. The topic for today will be to discuss NetApp's Data ONTAP operating system, the Clustered ONTAP mode, 7 mode, doing a bit of a compare and contrast, and just really a conversation about the two operating modes. So in terms of the agenda for today, I'll do a quick Datalink general overview, just kind of a recap of where we're at coming into 2014. What is Clustered Data ONTAP? How it compares to 7 mode, a discussion of which version is right for my business, and then how do I get from 7 mode to Clustered ONTAP for customers that are currently running 7 mode. At the end, we'll have time for some questions and answers. And as Jim mentioned, their questions will still be available to be asked post the presentation today. So starting first with the general Datalink snapshot of where we're at. I realize that many people are already familiar with Datalink on the call, maybe existing customers and employees, but just kind of a quick review where we're at. We've now grown to over $500 million as a public company, continuing our top partnerships with NetApp, Cisco, VMware, and others. We've grown to over 500 employees. We've held our sales staff fairly static at 85, but have grown to over 160 field engineers and architects and more than 75 support and managed services engineers. That number will continue to grow up throughout 2014, both through organic growth and our typical acquisition cadence of 12 to 18 months. So we're definitely not standing still. We're going to continue to build a solid foundation that customers can rely on going forward. Our value proposition has not changed. I won't spend too much time on this slide, but we're going to be concentrating on storage today, but we've continued to expand our expertise in the other areas of the data center infrastructure, networks, servers, cloud and orchestration, continuing to provide a unbiased approach that is results-oriented rather than based on what the manufacturers want to lead with to just try and rack up sales. So as I mentioned, we've gone beyond storage quite a bit. I also want to mention our advanced services capabilities that some may not be familiar with around business continuity, cloud enablement, and we also have a lot of capabilities around migration, which is what we'll be focused on later in this presentation when talking about moving from 7 mode to cDOT. So moving into the meat of the presentation, talk about what is Clustered Data ONTAP. So the intention behind Clustered ONTAP is to provide virtualization of storage access. So we're going to take the hardware that NetApp has been using for a number of generations and a number of years, the same storage controllers, the same disk shelves, really the same basic infrastructure, and then connecting them together in a different way using a dedicated dual fabric 10 gig Ethernet interconnect that allows us to aggregate all of the system resources from a network perspective, a compute perspective, a disk perspective, into a pool of resources that can all be virtualized and then used to provide data services in a customer's environment. So the way that this works is that we take a lot of the pieces that have existed for a long time, like Waffle, and the way that RAID works, so RAID DP for the double parity capability that has existed within ONTAP for many years. And what we essentially do is we kind of peel the layers apart a little bit and put in a networking layer that allows us to provide the scale-out capability of Clustered ONTAP. So the front-side networking layer consists of two pieces, what's referred to as the network blade or end blade that provides the NAS protocol access. This is the traditional CIFS and NFS capability that users know and love about NetApp. The SCSI blade provides the same front-side protocol access but focused on the block support, so iSCSI and fiber channel connectivity along with FCOE. And then on the back end we have the actual storage mechanism where Waffle lives, and that is called the data blade or the D blade. So this is the part of Clustered ONTAP that communicates with the back end disk shelves, does all the RAID work, all of the Waffle work. This is where snapshots reside, flex clones, all of the things that have existed for numerous years within ONTAP. So then the other things that have been added is a few other pieces. So the CSM is basically the configuration database that is what provides the connectivity between the end blade and the D blade and the SCSI blade, and allows us to essentially create a virtualization of access. So we can separate, instead of access being focused like 7 mode, where if a request hits controller 1, it can only communicate with disk on controller 1. Now we have the ability to essentially have an any-to-any connectivity, where a client that connects to a front-side connection, whether it be block via iSCSI or fiber channel, or to a NFS or CIFS connection, that can access storage resources on the D blade on any other node. So in this particular slide, we show essentially 2 nodes, and client requests can come in on node 1, but they actually have the ability to access information stored on the D blade of node 2 in a very seamless fashion. So this shows essentially the alternate client access. So now instead of it going directly to the D blade on the local host, it's able to use that dedicated 10 gigabit Ethernet cluster interconnect in order to get to the backend D blade on node 2. So the way that the front side connectivity works is through what are referred to as logical interfaces, or LIFs. So a LIF is really a connection on the end blade or SCSI blade side that it goes out to the client-facing network. So this is the part that's going to integrate with the network environment in your existing data center. So LIFs are used for essentially all external access to the storage array. There are a variety of different LIF types that are available. So for example, that we can create a management LIF that is used to connect to the array for the purposes of doing array administration or for other applications to integrate with the snapshot or snap mirror functionality. And those LIFs are not allowed to do any data protocol access for security reasons. Conversely, we can create a data LIF that can serve data out the front side where management access is restricted, and it's not possible to connect to those LIFs for the purposes of running the array management interface, again, for security purposes. In a lot of cases, these are on completely different networks. So for example, on the management side, there may be a fairly low-cost, low-resiliency gigabit Ethernet network that's provided for management, while a highly available, high-performance 10 gig interconnect or 8 or 16 gig fiber channel SAN environment is used for the front-side data protocol access. The important thing about these LIFs is that they are abstracted from the connectivity to the data itself by the cluster network. We may access data that's stored on the local node, but we may not. We may actually access disk that's allocated to a different node. For the NAS and the management LIFs, the other thing that we have the ability to do is move them. So the animation that we're showing right now is actually the movement of data on the back end, which we can also do seamlessly. This is something that's very different from the way that 7 mode works. So in a 7 mode environment, if we create a volume on a particular aggregate, it is essentially stuck there. We have some limited ability to migrate a volume for block protocol access within the same controller, and no ability to do that for NAS, and no ability to move from one controller to another. With Clustered ONTAP, because of the virtualization layer, we have the ability to pick up a volume from any aggregate and move it to any other aggregate in the system of our choosing, all online, all non-disruptively. This can be to a different aggregate on the same node, or it can be to an aggregate on a completely different node in the system. the connection to the client, which is always done through the LIF, isn't affected by this move at all. But not just volumes can move. We also have the ability to take a LIF, in the case of NAS protocols and admin protocols, like I'd started to say, and migrate that to a different node. Now, one important point about the way that the block protocol LIFs work for iSCSI and for Fiber Channel. These LIFs don't migrate. Instead, we always ensure that we have LIFs created across the multiple controllers in the environment, and then we rely on host-based multipathing and ALUA to recognize that a one path or another has been changed to become the active optimized path. So in the early part of the animation where I created the volume or moved the volume from the right side to the left side, with block protocols we will rely on ALUA to recognize that a different lift on the left side controllers is now a preferred and optimized path rather than what's on the right side. So there's a lot of things that we can do with this ability now that we can migrate data around non-disruptively. We can migrate the access to clients non-disruptively, such as the animation that we just watched, which is to replace hardware. So the hardware becomes essentially a non-critical asset from an actual data persistence standpoint. We can swap it out, we can upgrade it, we can remove it. All of these things can be accomplished without impacting availability to data. Once we've accomplished a particular replacement of any of the hardware, we have the ability to kick off the process to migrate the data back from the old controllers to the new controllers that have replaced it. Not entirely sure why that animation didn't reflect that stage, but apologize for that. But that was the intention, was to essentially, in the end, see if we can get it to kick over. No, it's just not going to. So the idea is essentially that we would move the volume back to the right side, we would move the lift back to the right side, and it would essentially allow us to completely upgrade the equipment without any loss of access. So based on the fact that there's a similar technology base and that it's NetApp, it's ONTAP, there's a lot of similarities between 7-mode and clustered ONTAP. I already mentioned that the hardware was the same, that the controllers, the disk shelves, all of those pieces really have become the same between 7-mode and cDOT. There's no requirement for brand new hardware just to get clustered ONTAP working. It's still unified, just the way ONTAP has been for its entire life. So the ability to do both SAN and NAS protocols, NFS up through NFS-v4 and PNFS, CIFS, including SMB2, Fiber Channel, FCOE, iSCSI, all those protocols are still available. The arrays are configured in HA pairs to provide complete redundancy and no single points of failure in the environment. That part also has not changed. RAID DP technology is also carried forward. So one thing to note here that is a difference is the fact that with clustered ONTAP, RAID 4 is no longer a recommended option on any sort of wide scale. RAID DP is essentially the default, and you have to override a lot of warnings if you want to use the older RAID 4 technology. Waffle exists in essentially its identical form in clustered ONTAP versus 7-mode. The aggregates are the same. The flexible volumes are the same. Snapshots. The ability to use quotas to control access to space allocation for users, groups, and queue trees. SnapMirror at the volume level carries over and functions very similarly. There's a couple of slight differences which I'll get to. Flash cache and flash pools. So NetApp's leading technologies for leveraging flash to accelerate storage performance work essentially the same way in clustered ONTAP as they do in 7-mode. So the ability to perform non-disruptive ONTAP upgrades carries forward, and all of the core storage efficiency technologies that many businesses come to rely on to improve the economic picture of their storage environment, such as deduplication, compression, the snapshots and flex clones and through provisioning, all of those capabilities carry forward essentially the same. So all of the other surrounding pieces, such as SnapDrive and SnapManager, those have also been updated to be able to support clustered ONTAP in a manner, if not identically, at least very similarly in clustered ONTAP as they do with 7-mode. Then also the on-command system manager and unified manager tools have also been updated in order to support clustered ONTAP. So one note about a unified manager in particular that I will point out. On-command system manager has the ability to manage at the array level both a 7-mode environment and a clustered ONTAP environment essentially at the same time with one installation. That's not the case with the on-command unified manager. So with OCUM, while the same software code can manage either 7-mode or clustered ONTAP, it can't actually do it at the same time on the same install. So it is a requirement that if you're introducing clustered ONTAP into an existing environment that already has 7-mode arrays and on-command unified manager, you would need to install a second instance of on-command unified manager in order to provide the same reporting and alerting on a clustered ONTAP environment. Now, of course, there are a number of key differences between what 7-mode offers and what clustered ONTAP offers. So in 7-mode, the Metro Cluster and Sync Mirror capability that kind of goes hand in hand with Metro Cluster is currently a 7-mode only capability. The ability to perform synchronous snap mirror is also essentially 7-mode. So if your business requires a synchronous replication capability, then that is something that is currently restricted to 7-mode. Also the snap lock capability, where we're able to make writes durable for a defined duration that is controlled either by an administrator or by an archive application such as Symantec Enterprise Vault, is currently also 7-mode only. The Q trees in clustered ONTAP have returned to their sort of original purpose and why the name Q tree exists, and that is really only for quotas. And so we have the ability to create a tree quota on a Q tree in clustered ONTAP, and we also have the ability to create an NFS export at that particular point. We no longer have the ability to perform snap mirror operations or snap vault operations at the Q tree level. That is a 7-mode only capability. One last kind of important capability that is 7-mode only at this point is data motion for vFilers. This isn't a widely deployed capability, but some environments leverage it quite heavily. This is the ability to take the 7-mode multi-store virtual filer or vFiler container and essentially seamlessly migrate it from one 7-mode controller to a controller in a completely different HA pair. For NFS and iSCSI, this can be a non-disruptive operation if the environment has been architected for that fashion. But that is a 7-mode only capability. Within clustered ONTAP, as I described earlier, we can seamlessly move resources around within a single array, but we don't currently have the ability to non-disruptively pick up a workload and transition it to a different cDOT array, as we can with the data motion for vFilers in 7-mode. So some of the things about clustered ONTAP that have been introduced and are different. So we have a single namespace. So the ability to aggregate storage resources from aggregates on multiple nodes could create quite a management mess if we didn't have a single namespace. So in a NAS environment, whether it be CIFS or NFS, we have the ability to essentially create a unified namespace using volume resources that are mounted into any kind of directory structure that you like. So whether you want to treat it like 7-mode and essentially have every volume mounted at the root of the namespace, that is certainly possible to carry forward, and it is an option that we often use when transitioning customers from 7-mode to clustered ONTAP. But with clustered ONTAP, we can take that quite a bit further to where we may have a parent volume that is for the generic purpose of, say, department shares, but then beneath that, if particular departments we need to have a large amount of allocation because one or more departments is particularly large or needs a particular type of capabilities, then we can create a volume for just that department, mount it in the namespace beneath the department share, and without having to create additional shares or having to create any sort of additional complexity within the environment. Another key differentiator is that clustered ONTAP offers a single point of management. One of the things about 7-mode is that while we have an HA pair and no single point of failures in what we would call a quote-unquote single array, when provisioning storage from the two nodes, they're effectively operating as two independent entities. So you'd have to go to controller A and do a allocation of a CIF share, or to controller B. It's not something that you can manage as a single point of management. System Manager kind of hides some of that distinction from you, but there's no getting around the fact that each controller has its own identity, its own captive storage to be provisioned. With Clustered ONTAP, we have a single point of management for the entire cluster, whether that be by a CLI or by System Manager or any of the other tools. It really only has a single identity when it comes to administrative management of the array. So with Clustered ONTAP, we also move beyond just non-disruptive upgrades of ONTAP into what NetApp calls non-disruptive operations. This is where we have the ability to non-disruptively do far more than we've ever been able to do with 7-mode. So hot adding a shelf is not a particularly exciting capability that's been around forever, but we now also have the ability to non-disruptively remove shelves beginning with ONTAP 8.2.1. The earlier animation showed a scenario where we were able to completely swap out hardware, controllers, disk shelves, everything, while maintaining non-disruptive access to all of the data. The entire purpose behind Clustered ONTAP is that once the array is up and running, there's no particular reason or planned maintenance event where we would ever need to take the array down, even as we fully life cycle the array and deal with the typical hardware failures that are going to happen with any piece of equipment. So we can handle and cope with all of these tasks while maintaining data access the entire time. So data motion for volumes, this was also and the lift migration were the two things that I showed in the animation earlier. Our ability to pick up a volume and move it aggregate to aggregate and pick up a logical interface from node to node is an integral part of Clustered ONTAP and is essentially how we do non-disruptive operations. So there are a couple of protocols that are unique to Clustered ONTAP that are not and will not be available in 7-mode. This includes the NFS version 4.1 and PNFS capability that comes with that. And it also includes CIFS 3.0 and then certain aspects of SMB 2.1 around leasing. So these are protocol capabilities that rely on parts of Clustered ONTAP that are unique or that would just simply be too significant of an effort to backport to 7-mode in order to make them to work. So there's a SnapMirror capability that is unique to Clustered ONTAP that is of particular importance to high-performance workloads, whether it's in data analysis, whether it's in rendering. There's a lot of different workloads where scale-out access to a single copy of data is important. In Clustered ONTAP, we can accomplish that with what's referred to as a load-sharing SnapMirror. So we can have a single read-write instance of the data on a given node, and then we can create load share mirrors on other aggregates on other nodes in the cluster that will allow for highly scalable read-only access to that data. For highly scalable read-write access, that's also a capability that exists kind of between both of them, but functions a little bit differently with Clustered ONTAP, and that is FlexCache. That's kind of a conversation in and of itself that may be tabled for a later date. One of the differentiators in the way that data protection works in Clustered ONTAP is that SnapVault now functions at the volume level. So Qtree SnapVault is something that has existed for a very long time and has been kind of the preferred data protection mechanism from a backup perspective within ONTAP. SnapVault continues to exist in Clustered ONTAP as of version 8.2, but it functions now at the volume level. It also has a few important differentiators in how it functions, and it is much more snapshot aware than Qtree SnapVault was, and it's far simpler to integrate with external applications like SnapDrive, SnapManager, and then with any particular custom application you may have running in the environment. One other key capability that is unique to Clustered ONTAP is infinite volumes. I have a separate slide describing infinite volumes later on, so we'll table that for the moment and get back to it. There's some scalability improvements. So beyond just the ability to aggregate hardware in a scale-out model, going up to 24 nodes, up to 56 petabytes of capacity in a single cluster that goes far beyond what 7-mode is possible. Even within the same hardware, single HA pair, we have increased volume counts on the larger controller models. And really what this is to accommodate is the fact that with Qtree SnapMirror and Qtree SnapVault removed, it is likely that the volume count needs to increase in order for Clustered ONTAP to support the kind of layouts that customers have grown accustomed to. And that's really the purpose behind the increased volume count. And the last sort of real differentiator comes to, from a management perspective, the CLI interface is completely different, completely revamped, and in my opinion, quite a bit more functional than 7 Mode ever has been. So things like tab completion, the ability to type a word, and as long as it's a unique match, you don't have to type out the full command. Very similar to what you get working with Cisco, iOS, or NXOS in that regard. So if I want to refer to a LIF, instead of having to type network interface, I can just do net int, and the Clustered ONTAP CLI allows that to work. And at any given point, I can type a question mark, and it will bring up possible completions and allow me to move forward just like you can with iOS or NXOS. Just in general, it is a far more capable CLI. And then because we've got the single point of management, I've only got one CLI instance, whether I log into a node management LIF, a cluster management LIF. As long as I've got management access on that particular LIF and connect via SSH, I will get the single same CLI instance, no dual point of management like you have with 7 Mode. So one of the key differentiators that allows for Clustered ONTAP to be able to support non-disruptive operations beyond just ONTAP upgrades is the way that it performs HA itself. With 7 Mode, HA is provided by what's referred to as controller failover. In this model, the failed system's identity continues on as a separate unique entity, essentially sharing the hardware of the node that survived the event, whether it's planned or unplanned. So we essentially have two identities sharing one piece of hardware, but the two identities remain completely independent when it comes to whether it's how you access it from an Active Directory or NFS perspective, worldwide port names. All of these types of things are kind of everything sort of remains the same. Nothing changes as we go and move. Where this becomes very interesting is when we go to do a give back. So in the 7 Mode environment, I would liken the give back to a pass in football, where we're essentially throwing the ball up in the air, and I don't want to say hoping too much. That makes it sound a little bit less constrained than it actually is. But we're essentially counting on the other controller in order to resume service. The important point is that data is not served until the give back completes. So as part of the process, essentially the surviving node shuts down its virtual instance of the failed over identity, and for that time period, you're not serving data for that identity until the second node finishes the give back, retakes over all of its aggregates, lights up all of its IP addresses or SAN identities, and then resumes serving data. So the only way that this can work is that network interfaces have to fail over entirely and can only go to essentially its partner node. You don't have any control over it. Everything just kind of comes. It's all or nothing. In Clustered ONTAP, the environment uses a very different concept in how it does high availability. So everything is still configured in HA pairs, but now we use something called storage failover rather than controller failover. Since we only have a single identity for the cluster, there's nothing on the identity side that needs to fail over. The identity is associated with the entire cluster, and that continues to run without any sort of need for a failover of that concept. What happens on a failover is similar in the sense that aggregates are taken over by the other partner in the HA pair, but what happens to the front side connectivity is very different. I already mentioned that when it comes to block protocols, we rely on ALUA, and so you already have LIFs present on the surviving node. As the aggregate fails over, all clients are updated via ALUA that the active optimized path has moved. It's very, very quick. It's very, very seamless. very, very non-disruptive to block protocol access. For NAS lifts, what happens is the lifts are migrated from the failed node to other nodes in the cluster. Now we have a complete control over how we want to have that happen. Those lifts, those NAS lifts, and the management ones for that matter, are not restricted to failing over only to their partner within the HA pair. You may choose to have lift failover go to a completely different set of nodes based on other criteria that you can define. In a typical environment, usually we are failing over to the partner in the HA pair. That is certainly the kind of default position, and it's the easiest one to contemplate. But that is not the only option, depending on what makes sense for a particular environment. Giveback functions even more differently in its ability to reduce the disruption to environment when it comes time to putting a node back in service that has had some kind of fault. Giveback returns the root aggregate first. We have a dedicated root aggregate that is essentially responsible only for booting the node. It can't serve any data. Really all it does is it stores configuration information about that node and logs, and then a core file if one was generated. And essentially we were able to give that root aggregate first, boot the node completely. This is a very important difference. So the node that we're putting back into service finishes the ONTAP boot process entirely, goes back into service with the cluster while it is not responsible for serving any data. It's able to verify its network connectivity, both in terms of Ethernet and fiber channel. It's able to verify its back-end connectivity with disk without being responsible for doing anything in a very safe and very controlled fashion. Once this process is completed, then aggregates are essentially handed back one by one at a time that works for the array's activity. So for example, if an aggregate has a lot of inbound writes where it needs to wait for the right time in order to transition the aggregate back, it may take several minutes. I've seen it take 10, 15, 20 minutes before all the aggregates finish giving back, because Clustered ONTAP is opportunistic in looking for the right time that won't impact access to data. And in fact, going beyond that, if it doesn't find the right time within 3 attempts, it will actually prefer to continue serving data with that aggregate in a sort of failed over state, as opposed to being disruptive about doing the give back to the original. If that were to occur, an auto support would get kicked off. There would be SNMP traps if you have that configured. The array would notify that one or more aggregates were not able to be give back. And then you can either manually try it yourself immediately, or you can schedule a time when you're aware, based on workload, that aggregate give back can be completed in a fashion that's completely non-disruptive. So I already sort of briefly touched on this, but just to kind of reiterate, with 7 mode and iSCSI, iSCSI IPs move over, and to an extent you can kind of get away with not running path failover software in an iSCSI environment, and there are a number of customers that essentially will function with a single software initiator, a single iSCSI portal identity target, and that is transitioned over as part of any SAN target failover. In Clustered ONTAP, that is not an allowed or supported configuration because the iSCSI targets don't move. They are tied to a particular physical port. They don't migrate. And we rely on a Lua to essentially identify which path is the current active optimized path for all I/O to the system. So then the obvious question that we run into today is, which version is right for my business? NetApp has not ceased to sell arrays configured and installed as 7 mode, even as the emphasis has certainly switched to positioning Clustered ONTAP where at all possible. So in terms of why a customer would choose Clustered ONTAP, non-disruptive operations is certainly one of the most compelling features of the way that Clustered ONTAP works. one of the things that Datalink has always been very clear on when positioning NetApp is that it is a very high value system from its rich data management capabilities, all of the fancy things I can do with my data from a snapshot and snap mirror perspective, how we can go with creating elaborate workflows with FlexClone. There's a lot of value that the array provides from a data management perspective. But the availability profile of NetApp has not really risen to what many people consider to be the top tier of Tier 1 compared with some of the arrays available like the HDS BSP or EMC VMAX. One of the design principles around Clustered ONTAP is to change that model to where now Clustered ONTAP can reach those levels of availability design with any array in the industry. So it isn't enough to simply support non-disruptive upgrades. That's kind of table stakes in the storage industry. It's really about that full suite of non-disruptive operations around any capability that you can think of. And in fact, NetApp has taken Clustered ONTAP a step further and supported the non-disruptive life cycling capability that has not been previously supported by the other vendors in a fashion that is an integral part of the system. So rather than having to run on an array and then if I want to non-disruptively lifecycle, have to go through a very unique, very unusual process with a lot of constraints, which is what essentially the other vendors that try and support non-disruptive lifecycling. And in the end, in many cases, they recommend that you only embark on non-disruptive lifecycling for the very small number of critical applications. And for the rest of your environment, you do it the kind of quote-unquote old-fashioned way, taking downtime as data gets migrated from the old to the new. This is a very challenging process when it comes to planning out maintenance windows, sequencing what applications go when. It really adds a lot of workload to the operations side of an organization. With Clustered ONTAP, we kind of take that capability and build it into the system as part of standard operations. So while you may not swap out an HA pair or a node on an everyday basis, the functions that enable that capability are tasks that you will do very frequently. So lift migrations, volume migrations, those capabilities are an integral part of the way that the array functions, so that when you go to do a life cycle, you're essentially just extending something that you're already doing on an ongoing basis. So that's obviously one of the very key capabilities that Clustered ONTAP can bring to an environment. So the single namespace for NAS. There have been products that are out there on the market that are third-party products that essentially this is all that they do. So Copia ARX, which was later acquired by F5. There are Rainfinity, which was eventually acquired by EMC. There were a lot of other players out there that would go to try and bolt on a single namespace, or you could think of an assist environment using DFS to provide this capability. Well, NetApp has taken essentially that capability and baked it straight into the array. So we have this ability to create a namespace and map volumes in from various aggregates and create a unified view of storage from a NAS perspective. Now, as I mentioned earlier, this is entirely optional. You don't have to create a hierarchical structure if that isn't what makes sense, but the option is there. One other thing that I think differentiates Clustered ONTAP from some other scale-out NAS providers is that rather than deciding on a single namespace as being the only way, if there are instances in which you want to have a second or third or more namespaces, you have the ability to do that within Clustered ONTAP. So the Clustered ONTAP physical array is essentially carved up into what NetApp refers to as a SVM, or a storage virtual machine. Each of one of these storage virtual machines is a point of data access management that's entirely unique within the clustered environment. It has its own lifts, its own management, and its own volumes. Now, at the physical level, it's all shared. So the nodes, the aggregates, front side ports, these are all shared entities. But within a given storage virtual machine, I have one Active Directory identity, I have one name within a NFS-v4 directory environment, however you want to kind of create that, and a global namespace within that particular SVM. For a lot of customers, they'll have one SVM, and they won't really worry about multi-tenancy and multiple namespaces or anything like that. But if you're an environment that does need highly capable multi-tenancy, then the ability to have multiple namespaces can be very important. In the 7-mode environment, we accomplished this with multi-store, but that was really oriented only around NAS, whereas the SVM capability within Clustered ONTAP bridges across all protocols, Fiber Channel, iSCSI, et cetera. So I touched on the name infinite vol earlier, and now I've got a slide that kind of shows how an infinite vol actually works and kind of describe a bit about what it's used for. So this picture, which references 811, even though we're now up to 821, shows kind of the way that an infinite vol works. And that is we're essentially going to aggregate capacity rather than taking a physical aggregate, creating one flex vol, and then that is the boundary of which I can provision data up to essentially 100 terabytes for a standard flex vol today. An infinite vol has the ability to take capacity across all aggregates, across all nodes, and put all of that together into what, from a client's perspective, looks like one single volume. Within this volume, it's a single pool of capacity, a single namespace. You can create whatever directory structure underneath it you want, but really it's just one giant pool of capacity that ONTAP itself will then take care of where it wants to write files on the back end of the system from an aggregate perspective. So the support today is for extremely large single file systems. So over 20 petabytes of raw capacity is supported, and this number is only going to continue to grow. So we can support up to 2 billion files in this single infinite volume with the maximum file size of 16 terabytes. Originally, this capability required dedicated gear, but with ONTAP 8.2, that's no longer the case. So now an infinite vol can be a shared resource within an existing customer or existing array in a customer's environment, essentially sharing the same hardware. Now there is one restriction, and that is that an infinite vol does have to live in a dedicated storage virtual machine that all it can essentially can live in is within that SVM. Nothing else other than that single infinite vol. But from within there, you can control connection to Active Directory, connection to LDAP from a NFS perspective, how you set up shares and exports, all of that kind of capability is held at the SVM level. So this slide shows NFS v3 in the most recent release. SMB1 has been added. But right now it is still behind from a protocol perspective. We don't have SMB2, let alone SMB3 support. Don't have full NFS v4, 4.1, and PNFS support. Really the use case behind an infinite volume is for kind of that extremely large bulk data storage application. It isn't something that we lead with when we're going to do home shares or department shares. Unless your home or department share environment is really so large that and where a namespace alone is not enough, then we could consider architecting an infinite vol around that capability. But by and large, the data that is going into an infinite vol is application driven, whether it be for archive purposes or video storage. There are a lot of use cases, but it's definitely something that we don't approach for really any NAS workload. So then why would a customer choose 7-mode? I mean, this is actually to an extent almost the more important question. NetApp's very clear focus is on Clustered ONTAP. It is their future direction. They are driving towards parity between Clustered ONTAP and 7-mode, and they've been very clear about what their future direction is. However, customers still need to run their business today, and there are a number of capabilities that are frankly not at feature parity within Clustered ONTAP. So a common complaint as Clustered ONTAP has rolled out is compatibility with current operating systems and applications. So whether you're still running applications on Windows 2000 or Windows 2003 and have not been able to virtualize, so you need SAN connectivity into that, or perhaps you've got older clients that are using CIFS capabilities that don't yet exist in Clustered ONTAP. 7 mode is still around, still been upgraded to the most recent release of 8.2.1, and offers the widest compatibility for current and sort of legacy operating systems and applications. Along with that, there's obviously an extremely extensive knowledge base for integrating with major applications. So the 7 mode environment has been around for over 20 years. And there's a huge knowledge base in terms of documentation and in terms of people, in terms of integrating 7 mode with application environments that are out there today. Support for MetroCluster, SnapBlock, data motion review filers. I already touched on that these are features that are 7 mode only today. Now, NetApp is committed to eventually bringing those over into the Clustered ONTAP environment, but the bottom line is that they haven't gotten there yet today. And so if any of these capabilities are critical to your environment, if you've got an archive application that you, whether it's for SEC 17A4 compliance or for some other purpose, you need to have a worm disk capability, then 7 mode is your obvious choice today. So as we've gone and had these types of briefings over the past couple of years, the question has shifted from where why would I want to think about going to Clustered ONTAP to why would I want to think on staying on 7 mode? That conversation is going to continue to shift, and then NetApp's ultimate goal is to essentially have why do I want 7 mode to essentially be you don't. But the fact is, for today, there are a number of workloads and use cases where 7 mode is the more appropriate choice. So some considerations that kind of go along with this conversation. There's no data in place upgrade path from 7 mode to Clustered ONTAP. So for an existing array that's running in 7 mode, it's got data on it, there is no data in place upgrade path, and we should assume that there never will be. The future is obviously a difficult thing to project, but at this point, it's not likely that it will ever happen. As a result, we need to migrate the data from an existing array on 7 mode to a Clustered ONTAP environment. There's very limited replication support between 7 mode and Clustered ONTAP. It's really only supported for migration. So SnapMirror has the ability to replicate NAS data from a 7 mode environment to a Clustered ONTAP environment using volume SnapMirror. Q-Tree SnapMirror and the 7 mode SnapVault will not work. Only the volume SnapMirror is allowed. And this is only currently available for NAS data. Any block data must be migrated externally. So this can be done either by the application itself in the case of, say, for example, VMware and its ability to do storage vMotion, or the ability within a operating system that has a logical volume manager, such as Linux or AIX, to pick up data from a existing LUN and move it to another. Or there are other methods. So whether it's secure copy or rsync or all the other fun ways that are available to migrate data, it must be done without the array's sort of direct involvement for block data. I mentioned that a dedicated root aggregate is required. So essentially each node in a cluster, whether it's 2 all the way up to the maximum of 24, needs to have 3 disks dedicated to the root aggregate. In a larger array, this is generally not a major concern or consideration. But for folks that wish to deploy, either because of the size of their business or the size of the site makes an array of the size of a 2220 or 2240 appropriate, this can become a bit of a challenge. I mean, this is space that is not accessible to serve data in any way, shape, or form. So you look at the dedicated root aggregate plus hot spares plus parity, you're looking at giving up essentially 12 disks worth of capacity before you can even begin to start counting data drives towards serving data in your environment. That's a non-trivial investment. Now NetApp is working on ways of ameliorating that particular requirement, but the bottom line is today it can be a little bit tricky if you're sizing a Clustered ONTAP for the very smallest footprint. And lastly, there is some additional infrastructure required with Clustered ONTAP. I've mentioned the 10 gigabit cluster interconnect that glues the nodes together in Clustered ONTAP. At the very smallest level, where we have a 2-node cluster, this is often accomplished without any sort of switches. We have two 10-gig connections on each of the nodes that are connected directly, often with twin X cables, and that is what is providing the node-to-node connectivity from a clustered ONTAP, ClusterNet standpoint. For anything larger than a 2-node, however, we do have to put switches in place that are 100% dedicated to clustered ONTAP. These cannot be shared for any other purpose, so it is an additional infrastructure investment. So NetApp provides a branded switch offering that is appropriate for environments that go up to 12 nodes. And then their supported option for larger than that is a Cisco Nexus 5596. With that environment, we can easily go up to the 24-node maximum. So by the time you've got to greater than 12 nodes, the cost of investment of those switches is generally not significant compared to the rest of the array, but it isn't zero, and it's definitely worth taking into account. So sort of the kind of final question is, how do I get there? If I'm on 7 mode today, how do I get to clustered ONTAP? As I touched on briefly, we can use SnapMirror for the NAS data, and we can use block application level external migration for the SAN data. But really the most important consideration is that there is a planning part of this involved. It's not something that we can essentially jump into without much thought or without much worry as to how it's going to be executed. There's a significant amount of planning and know-how and guidance that goes into executing a 7 mode to clustered ONTAP transition. And to that end, one of the things that Datalink has really focused on throughout the past, I would say, 18 months is really ramping up our capabilities around how to perform this type of data migration. So within our advanced services organization, we have a very specific group of individuals that concentrate on doing data migration services and in fact concentrate on executing 7 mode to clustered ONTAP migration plan and execution. So whether we assist only with the planning, assist only with the execution, or assist with the entire process, that's something that Datalink would be more than happy to partner with you on. So a couple of highlights. Datalink was named NetApp's Clustered ONTAP Partner of the Year for 2013 as a reflection of the significant investment that we've made in clustered ONTAP knowledge, test facilities within our lab. We have 4 fully functional clustered ONTAP arrays of various sizes and purposes within our environment. It's something that we consider to be very critical for our customers going forward. We are NetApp's largest commercial partner worldwide. This is critical in terms of our expertise and the relevance that we have with NetApp. So we participate in all relevant beta programs, early access programs, so that we can be ready and provide capabilities to end customers the moment that they're available from NetApp. And we've implemented more clustered ONTAP solutions than any other NetApp partner, and it's actually not even close. And as a percentage of our business for 2013, Datalink had the highest clustered ONTAP implementation rate of anybody, including NetApp themselves. So we did more clustered ONTAP as a proportion of our business than anybody in the world. So with that, we are rolling close up to the top of the hour. So I wanted to take a moment and ensure that we had an opportunity to answer a couple of questions that have been identified as we've gone through this session today. So it looks like we've got a couple of questions. So the question is, the migration of SnapMirror to 7 mode to cluster node of traditional volumes is not supported from my understanding. That is correct. So if we look at customers that are still using traditional volumes rather than flexible volumes, there is no within the array methodology for us to be able to do that kind of migration. There are a couple of methods that we could use. On the source array, we could consider using traditional methods to get from traditional to flex, so NDMP copy within the array, for example. Otherwise, we also could use NDMP copy in order to essentially copy the data from the traditional volume on the 7 mode side to the clustered ONTAP side. One thing to note, that entire copy operation would have to occur, at least the final cutover, while access to the data set was offline. NDMP is not something that is going to be necessarily very quick in the grand scheme of things. And so while we could do kind of a full baseline plus an incremental, that last incremental is something that would have to occur while access had ceased. Otherwise, would have to be an external migration. So a question about how many clustered ONTAP that we've done. I don't have the absolute number. That's something that we certainly can provide. I mentioned that we had the largest percentage. I believe the number was 27% of our ONTAP business last year was clustered ONTAP, which is quite a bit larger than the second place organization, including NetApp itself. Very big focus. It's a fairly good sized number, but I don't know what it is off the top of my head. So a question about segregating SATA and SAS. They do not need to be served separately. So the rules around mixing disks and how disks are essentially allocated within clustered ONTAP are the same as in 7 mode. So they're restricted by aggregate. So an aggregate is either entirely SATA or it's entirely SAS. The recommended RAID sizes and recommended around how many disks to put into an aggregate, all of that, those best practices carry over from 7 mode to clustered ONTAP, as does all of the flash pool capability, where we can then add flash to either of those types. So that part, there's no need to separate a SATA pair and a SAS pair separately. So a question about, is there still an 8-node limitation for iSCSI? Yes, there is. So that applies to both iSCSI and FC. So the 24-node capability is something that only exists within NAS protocol environments. Any environment that array that has a block protocol enabled will be restricted to 8 nodes at this particular time. And I don't have any insight into if or when that is something that will be changed in the future. So any other options for a customer who relies on data motion for vFilers? So at this time, in terms of generally released information, there isn't really anything I can describe around array to array non-disruptive migration of the storage virtual machines. But there is a so really data motion for vFilers remains unique to 7 mode. The only thing I'll add is stay tuned, but some things might be a little while. Let's see here. So a question about snapdiff support. So snapdiff, so the question was specifically to TSM. But snapdiff itself, I don't know about specific to TSM, but snapdiff has been implemented in clustered ONTAP 8.2. It is, the API calls are a bit different in clustered ONTAP versus in 7 mode. So while snapdiff is available, it would be up to IBM to essentially add support for clustered ONTAP versus the 7 mode. So with that, we've reached the point where we've gotten to the end of the time that we have today. I really appreciate everyone's time. We will continue to take the questions that people have asked, and for the ones that we didn't get to, we will have a follow-up email to everyone that contains all of the questions that were asked, the answer that provided, and then for any question that I was not able to get to, apologize for the short time, but we will answer that question offline and make sure we get back to you.
Thanks a lot, Jason. That's a lot of information. The address to send your questions after the session is techtuesday@datalink.com. And, like I said, and just to reiterate what Jason said, we'll get you an answer. And the transcript of all the Q&A that went on today will be sent to all the attendees. So if your email address was in there when you registered, you should receive that. I've got the tentative schedule for upcoming events. March 18th at 2 o'clock, we're going to be doing a deep dive into NetBackup 7.6 and Ops Center. That's a follow-on to last month's Tech Tuesday. On April 15th, or Tax Day, it looks like we're going to be talking about the Cisco Nexus Management Best Practices. So hoping you can join us for those, and thanks again for taking the time out to spend it with us today, and hope to see you again in a future event. Thanks, everybody.